So you may already know a basic formula or algorithm for finding the area of a triangle, but we are in this video going to use the moving and additivity principles that we talked about in the last section to find the area of triangles and then to determine why that formula is what it is. So here I have a triangle. We could count up the squares just like we did with a rectangle. However, we have a little problem because we have some pieces that are not complete squares. They're parts of squares, and we don't even know how much of a part of a square that is. But what we can do is we can use the moving and additivity principle to turn these parts of squares into actual squares. So that's what we're going to do. We're going to use 3 different methods. So the first method, I'm just going to identify parts of this square and try to match it up with other parts of the square. So in other words, this part here looks like that part here. So I'm going to theoretically get rid of that part, or maybe I should just black it out instead. So it's no longer part of the triangle that we're looking for the area of, and instead it's attached down there. I'm going to do kind of the same thing with some of these other little parts. Let's see, this piece here, and you can try this out on your own, kind of matches with this piece. Let's see, this little piece kind of matches with this piece up here. Let's see, what else could we do? But you understand the idea. I could take this little piece here and match it down here. So now let's see what I've gotten rid of. I've gotten rid of this piece. I've gotten rid of this piece. And I've gotten rid of this piece. And now I've made these whole squares. So instead of having all these little parts of squares, now I have whole squares, and now I can count them up. So let's do that. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square units for my triangle. So now I'm going to try a different method, but I'm still doing the moving and additivity. So I'm taking parts of the triangle and trying to match it up so that it looks like kind of like a square or a rectangle. So this time I'm going to take a big chunk. I'm going to take this big triangle here, and I'm kind of spin it around and redraw it upside down over here. So that this original part of the triangle gets moved and added back on to our triangle. So now we have a whole rectangle, and we know how to find the area of a rectangle, right? So here we should be able to see 3 times 4, gives us our 12 square units again. All right, so those 2 methods gave us the same answer. Let's try method 3. So for method number 3, what I'm going to do is I'm just going to flip this whole triangle over and say, wow, this triangle looks like the upside down version of the other one. So if I duplicate that triangle, I get a giant rectangle. Now, and this time I can find the area of that giant rectangle. 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6. And that is 24 square units. But wait, units. But wait, I doubled my triangle. So what do I have to do to my 24 square units? I need to divide it in half. Divide by 2. And now I get my 12 square units. So this may look familiar to you because this method 3 is really the one that we know of that gives us that standard formula or algorithm for a triangle. So what I did here was I took my base times my height of my rectangle, base times height, 4 times 6, and then I divided by 2. And that gives me the area of a triangle. Another way to write this formula, in case there's actually a few different ways to write this formula. We could say base times height times 1/2 means the same thing. We're still getting half of that big giant rectangle, base times height. So we could also say base times height divided by 2, something like that. So just different ways to write that same formula, but hopefully you can now see the reason we use the base times height times 1/2 or divided by 2 formula for the area of a triangle.